right, we are looking at target 4.2 mastery learning objective. I can find the expected number of outcomes by creating and using frequency tables to find theoretical and experimental probability. So, vocabulary. What is theoretical probability and what is experimental probability? So theoretical probability is probability from the actual amount, I would say. You didn't do anything. And we'll see kind of examples of this. And then experimental probability is the probability from the number of times it occurred. And you did an experiment. So let's look at an example of these to kind of make it make a little more sense. So example 1, if Jane is rolling a fair-sided die, what is the probability of rolling a 5? Well, I know on a fair-sided die, right, I have a 1, 2, 3, 4, 5, 6, right? So the probability of rolling a 5 is, well, the actual amount of 5s is there's 1 out of 6. Okay? This is your theoretical. Looking at part B, if Jane rolled the die 30 times and she got a 5 7 of those times, well, the probability of rolling a 5 there, well, I got a 5 7 times out of 30, which is not quite the same as 1 6. And this is your experimental. So I actually did something, right? So an experiment is very loose here. So you do something, right? Actually did something. That's experimental. Theoretical, I didn't actually ever do anything, right? I just looked at the die and went, I'll probably get a 5 1 out of 6 times, right? But when I actually rolled, I got it 7 out of 30 times. Okay? Alright, Harry picked a queen from a deck 9 out of 104 times. Compared to the theoretical probability, how did Harry do? Okay, so you can do this to see, like, is it fair, right? Is your die actually fair? Do we actually think there's, like, the right number of queens in this deck? Whatever, okay? So, I actually picked a queen. That's experimental, right? So my experimental probability is 9 out of 104, which is approximately, a lot of times when we're comparing, we'll put it into a decimal in order to compare that. And again, we can hit Control and then Enter to get that decimal, and that's 0.86, or 0.086. Now, theoretical. Okay. Well, if I look, I pulled it up, I know. So if I look at this deck of cards, right, kind of looking over here, we're finding the probability of a queen. Well, there is 1, 2, ooh, don't click on it. Oh, okay, click on it. 1, 2, 3, 4 queens. And if we counted up all of these, there are 52 cards in a deck. Okay. So theoretically, you would pick a queen, right? There are 4 chances for a queen out of 52 dark cards in a deck. 4 divided by 52 is 0.076. So Harry did better, right? It's slightly higher. So Harry did slightly better than you would think. Okay. So now we're going to go the opposite way. Okay. So that's experimental versus theoretical again, right? And we can compare the two. Now, if we look at example 3, right, Doug asked a random sample of 50 classmates whether they were interested in extending the school year. The results are shown in the table below. And now if I did something 250 times, I can find what I would expect. Okay? So, he asked 50 classmates, and I want to know how many students should he expect to be in favor of extending the school day. Well, the probability of yes, right, being in favor is 12 out of 50, which equals 6 out of 25. So, what we call it as our expected value what you would expect your experimental probability to be is the number, is the total, times the probability. Okay? So I know the total number of students I have is 250 students. And our probability we just found to be 6 out of 25. And we get 250 times 6 out of 25 is 60. So I would expect, if I ask all 250 students, that 60 people would say, yes, I'm in favor. Okay, so this is a lot of what polling is. If you see polling with political stuff or whatever, anything really, right? They ask a certain subset and go, okay, well if I then took everyone, I would assume this many people. I assume this subset of people is comparable to everyone. Okay. Maybe or maybe not true. We actually look at that more next unit. All right, let's look at our next page. So then we have what we call a relative frequency table. We actually already made a relative frequency table in class. So a relative frequency table lists options and technically a relative frequency table has the probabilities for it. So this isn't quite a relative frequency table yet. We're going to kind of finish making that, or use it, at least use the frequency table to create, to answer these questions. So what is the theoretical probability of spinning a green, right? Because he spun this spinner 40 times and recorded his results over here. So the theoretical probability of spinning a green, right? Well, theoretically, there's 1 green out of 4 options. So I didn't actually have to do anything. What is the experimental probability of spinning a green? Right. I'm going to come over here. Experimentally, I got a green 6 times. Out of, you can add all these up, but it also told you It was out of 40, okay, which is 3 out of 25. If Bradley spins the spinner 200 times, how many times would you predict the spinner lands on green? So, for expected value, we always use expected value. EXP is also experimental. Expected value always uses the total times the theoretical. Okay, you never use your, unless it's the only thing you have, which sometimes happens, but you never really want to use your experimental probability as much to find your expected value. You'd always want to use like your theoretical. Sometimes, like in the cases of like surveys, all you have is the experimental. It's the best you can do. But if we have the theoretical, probably we'll use that. So our total is, I'm spinning the spinner 200 times. My theoretical is 1 out of 4. So I would expect 50 times to land on green. All right, if we look at our next example, Clara rolled a standard 6-sided die 50 times. She rolled a 1 6 times, a 2 12 times, a 3 7 times, a 4 7 times, a 5 8 times, and a 6 10 times. So I'm going to create a relative frequency table. Okay? So for each one, we want the frequency and the probability. And then what are my options? I can get a 1, a 2, a 3, a 4, a 5, a 6, and then we have our total. Okay, so I got a 1 6 times, a 2 12 times, a 3 7, a 4 7, 8, and 10. These should always add up to the total. Usually it will tell you what your total is. She rolled the die 50 times. Right? And I believe those do add up to 50. I hope. Then we have our probability. So the probability is just that. We know how to find probability. I have 6 out of 50, which is also 3 out of 25. 12 out of 50, which is 6 out of 25. 7 out of 50 does not reduce. Does not reduce. 8 out of 50, which is 4 out of 25. 10 out of 50, which is 1 out of 5. And then our total probability, remember, is 1. So these always add to 1. Okay, because if I add up everything, and my probability is 100%, right? So 1. And you can check, and those would add up to 50 out of 50 or 1. Okay. All right. Looking at example 2, Rick picked up a bag of marbles. Okay. Inside there were 3 red, 5 blue, 1 yellow, and 2 green. He had 25 different people pull a marble out of the bag without looking and then put the marble back. A red marble was chosen 8 times, a blue marble was chosen 11 times, a yellow marble was chosen 2 times, and a green marble was chosen 4 times. Okay, so we have both theoretical and experimental. So we're going to do theoretical frequency, and then that's supposed to be a Q. Theoretical probability. Can't spell today. Experimental frequency and experimental probability. And we have red, blue, yellow, green, and our total. Okay, well, theoretical, remember, happens before we actually do anything. It's not that there. Okay, so if all I know is if I have this bag of marbles, that's our theoretical. So how many marbles are in the bag, right? Well, there are 3 red marbles in the bag, 5 blue marbles in the bag, 1 yellow marble in the bag, and 2 green marbles in the bag. Okay? If I add all those up, there's 11 total marbles in the bag. Okay? So that's just theoretical. Right? We haven't actually done anything with these marbles. Then, when I asked people to actually grab a marble, they chose the marble 8 times. They chose the blue marble 11 times, the yellow marble twice, and the green marble 4 times. Okay. How many times was this? This was 25. So our total for our theoretical is not the same as the total for our experimental. So now finding our probability, we have 3 out of 11. That doesn't reduce, but I'm also going to put it as a decimal so we can see how these compare. And that's 0.28. Blue is 5 out of 11. Which we get about 0.45. 1 out of 11. Control Enter. We get about 0.0. We'll say about 0.10. And 2 out of 11 is about 0.18. And again, these should add up to about 1. We were doing a lot of rounding on this, so I think it's a little off. I think it's like a little higher, but for the most part, they should be about 1 when you add them up, right? And if you add up the fractions, that's exactly 1. Same thing for our experimental. We have 8 out of 25. Control Enter, which is 0.32. So those are pretty close. 11 out of 25. Which is 0.44. That one's really close. 2 out of 25. Which is 0.08. Which again, kind of close. And then 4 out of 25. Control Enter. Which is 0.16. Again, kind of close. Okay? So again, if I added all of these up, I should get 1. Okay? Alright. And that's it with more of our probability, and so we will be looking over more of this on Monday. Have a good weekend.